Hey class, today we're going to talk about one of my favorite challenging yet still fun activities in chemistry, and that's balancing chemical equations. Now we know, because the law of conservation of mass states that we cannot create nor destroy matter, we have to have the same number of products as we do reactants. So products have to equal reactants. You got to have the same number of atoms on both sides of the yield arrow. And because of that, sometimes our reactions don't produce the correct number. We have to balance it by adding coefficients. Now, this can seem confusing, but once you get the hang of it, it'll actually become something you enjoy. It's challenging. It's not as boring as some of the other stuff. If you follow these steps, you're going to be a good balancer. First step, draw a line underneath your yield arrow to separate your reactants from your products. Then write down which elements you have. We got nitrogen and hydrogen. We've got to have the same ones on the other side. Then count your atoms. Be sure to count carefully, especially when you get to some of the more complex ones. Nitrogen, we got 2. Hydrogen, we have 2 as well. On the product side, nitrogen's only 1, hydrogen is 3. It's unbalanced. We have to balance both of these. In this one, it's very simple. We have 2 what I like to call wild cards. Anytime you have an element by itself, either a diatomic element or, as we'll see later, metals sometimes get written by themselves: lead, iron, zinc. Anytime something's by itself, save it for last, because you can write a coefficient in front of this without changing anything else. We have 2 of them on this problem. It's not going to be very hard. Let's start with nitrogen. If we want to have 2 nitrogen on this side to balance this one, we got to add a 2 for a coefficient. 2 times that 1 that's not necessary gives us 2, but it also changes our hydrogen. 2 times 3 is 6. Nitrogen's balanced, hydrogen's not, but can we make a diatomic hydrogen equal 6? Most certainly can, by doing that. We add a 3 in front of the H2, changes that hydrogen to 6. We've got 2 and 6 on both. And for a place marker, I will generally put a 1. So let me know that I'm done with this problem. Not too bad, right? Let's look at this one. It's so-so. Okay, bad joke. I'm sorry. Sulfur, we've got 8. Oxygen, we have 2. Other side, sulfur is only 1. Oxygen is 3. Neither is balanced. If you look at this, can you make oxygen balance with 1 move, a 2 and a 3? No. Can you make sulfur balance with 1 move, 8 and a 1? You can do that. Add an 8 right there. Now sulfur's balanced. You have to recalculate your oxygen. 8 times 3 gives us 24. Now our sulfur is good. We got to make oxygen equal 24. It's a diatomic, so 24 divided by 2, we need to put a 12 right there. And there's our place marker. Does it make sense a little bit? Let's try some more difficult ones. All right. Mercury 2 oxide produces mercury and oxygen. Still just two elements. Over here we've got 1 and 1. Over here we've got 1 and 2. Everything's almost balanced except oxygen. To make oxygen 2 on this side, we put a 2 as a coefficient. But that changes mercury to 2 as well. But we have a wild card for mercury on this side. So all we have to do is place a 2 right there, and now we're balanced. 2, 2, 2, 2. There's our place marker. That one was still pretty easy. Let's move up. 3 elements. Zinc, hydrogen, chlorine. Now go through and count your atoms. Zinc is 1, hydrogen's 1, chlorine's 1. On the product side, zinc is 1, chlorine is 2, hydrogen is 2. So right off the bat, look at your equation and see zinc is a wild card, and so is hydrogen. So that leaves us to balance chlorine first. Chlorine has 2 on this side and 1 on this side. We need to make this chlorine 2. We can do that by adding a 2 in front of it. That also changes hydrogen to 2. One move. Sometimes chemistry does us a favor like that. Put your place markers in, and that's what you have. All right, let's keep going. All right. Looks like we got 4 elements on this one. We got silicone, chlorine, oxygen, and hydrogen. Count your silicone. 1. There's 1 right here as well. It doesn't matter if you count 1 element at a time or 1 side at a time. I just kind of do whatever comes natural to me. Chlorine is 4. On this side, chlorine's just 1. Over here, hydrogen is 2. Hydrogen over here is 4, but look, there's hydrogen in both compounds, so you have to add them together. 4 plus 1 gives us 5. Oxygen, 1 oxygen there, and 4 here. Do you have any wild cards? No. The closest thing you have to a wild card is HCl, hydrochloric acid. So let's start with silicone and oxygen. Silicone's already balanced. So let's go to oxygen. Oxygen, we need 4 on this side to match the product side. How do we do that? We got to make this 4. That changes our hydrogen count though. 4 times 2, 8. Okay, so silicone's good, oxygen's good, but now chlorine and hydrogen are off. How to make chlorine 4 on this side? We just simply put a 4 right there. Chlorine's good. Now we got to recalculate our hydrogen. 4 times 1 is 4. And then don't forget we have 4 in the first compound. 4 plus 4 is 8, and looky there. Got lucky again. Okay, let's look at this. This is a fun reaction. Anytime you add an alkali metal to dihydrogen monoxide or water, you get an explosion. So this is quite a violent reaction as well. You've got 3 elements. Now go through and count. 1 sodium, 2 hydrogen, 1 oxygen. 1 sodium, 1 oxygen, 3 hydrogen. Sodium and oxygen are already balanced. You have a wild card, sodium, right behind him is hydrogen. So you want to save them for last, but oxygen's already balanced. So move on to the next. Hydrogen, 2 and 3, can you make those balance? No. You have to have an even number on the product side for this to work because hydrogen is H2. So to find an even number, you can't go down. Can you get to 4? Can you make hydrogen 4? Well, if you added something here, you're obviously going to make it more than 4. But what if you added a 2 right there? 2 times 1 is 2, plus 2 gives us 4. But that screws up sodium, changes that to a 2, and oxygen changes that to a 2 as well. You still have to make this side 4. 2 times 2 gives us 4 on that. It also changes our oxygen, which we appreciate because it changes it to 2. Now we just use that wild card to finish it off and our place marker. 2, 2, 2, 1. And you'll hear me refer to these as the coefficients. Oops, I forgot the place markers on this one. You'll hear me refer to these as the coefficients. So the answer would be 2, 2, 2, 1 or 1, 4, 1, 4, etc. All right, let's move on up. Hopefully this is starting to make sense. All right. Hydrogen, phosphorus, oxygen. Okay, let's go through and count. Hydrogen on this side is 3. Phosphorus is 1. Oxygen is 4. Go to the other side. Hydrogen is 4, but then look again. It's in both compounds. 4 plus 2, 6. Phosphorus is 2. And oxygen is 7 plus 1, which makes it 8. Now, obviously, we don't have a wild card, but H2O is close. So let's do phosphorus first. You gotta be careful when you say that. To make this side 2, we just put a 2 there. 2 in the coefficient. Now go back and update everything. 2 times 3 is 6 hydrogen. And then 2 times 4 is 8 oxygen. And your place markers. That was pretty lucky. You would never know with one move you could balance that equation by looking at it. Okay, take a look at iron. Iron plus oxygen gives us rust or ferric oxide. Only two elements, but you still have to do a little thinking on this one. Iron, this is 1, oxygen is 2. Iron is 2, oxygen is 3. Iron over here is your wild card, so save him for last. To balance oxygen, will 2 and 3 ever balance? No, not with one move. You've got to make them their least common multiple. And in this case, you can never make this 4, but you can make it 6, which this one can also match. So how do you make this side 6? Put a 3 right there. 3 times 2, 6. Opposite side. How do you make this 6? Put a 2. 2 times 3 is also 6. But that changes your iron to 2 times 2, which is 4. But we're not sweating it because we've got a wild card over here. Put a 4 in front of the iron to make it 4 to match up as well. Pretty small, pretty short, not too hard. Let's go a little bit more in depth. Number 9 has a special case that I'm going to come back to in a different video. All right, let's see here. Aluminum, oxygen, hydrogen, and sulfur. I don't know why I went all out of order on that. Aluminum, how many do we have? Just 1. Remember, that 3 only applies to the parentheses. Oxygen, we've got O1 times 3, which is 3. It's in both compounds. 3 plus 4 is 7. Hydrogen, 3 times 1 is 3. It's in both compounds as well, so 5. 3 plus 2. Sulfur, only in one compound. And it's only 1 atom. All right, the other side, Al2. Oxygen, SO4, but there's 3 of them, so 4 times 3 is 12. 12 plus 1 is 13. Okay, no hydrogen here, only on this one, which is 2. And then our sulfur, we got S1, but we got 3 of those sulfates. So we've got 3. Where do we start? There's no wild cards, but H2O is the closest thing we have, so save those for last. So we'll go ahead and start with aluminum. To make aluminum balance, pretty simple. We put a 2 right there. But now we got to go back and update everything. So 2 times all of this. So for oxygen, oxygen was 3. We got 2 of them. Now it's 6. 6 plus 4 is 10. Hydrogen. 3 times 1 is 3 times 2 is 6. 6 plus 2, 8. And then sulfur didn't change. So aluminum's good. We're saving these for last. Let's make sulfur fixed. We want to make 3 on the reactant side, just like we do on the product. So we're going to put a 3. Now we're going to go back and update again. This is where it gets challenging. 3 times 2 is 6. 3 times 2 is 6. 6 plus 6, 12. Oxygen was at 4 times 3 is 12. So if you want to make a note, you can do 12. Over here, oxygen was O3 times 2 is 6. 6 plus 12, 18. Okay, we're getting somewhere. Now we're at our oxygen and hydrogen. Oxygen looks pretty rough. Can you make hydrogen a 12? A lot easier. 12 divided by H2, which is 6. Now go through and recount. 6 times 2, 12. That's what we want. 6 times 1 is 6. 4 times 3 is 12. 12 plus 6, 18. And there we have it. That's the most complicated one we've done so far. Let's do one more and then I'll let you go. Iron, sulfur, oxygen, hydrogen. You know what? Let's move this up. All right, there we go. Iron, sulfur, oxygen, potassium, we already have oxygen, hydrogen, 5 elements. Now let's go count them. Fe2, nothing in that one, 2. Sulfur, S times 3 is 3. No sulfur here. Oxygen, 4 times 3 is 12. And then we have 1 there is 13. Potassium, just 1. Hydrogen, just 1. Other side. Potassium, 2. Nothing in that one. Sulfur, 1. Nothing in that one. Oxygen, 4. And then we have oxygen over here as well. So O times 3 is 3 plus 4, 7. Iron, just by itself. Remember, that 3 doesn't apply to iron. So we just have 1. We've already done oxygen. Hydrogen, H3. All right. Do we have any wild cards? No. Do we have anything close? KOH is about the closest thing we have. That's the most simple compound. So let's save KO and H for last. So first up, iron. How do we fix iron? We need 2 over here. We need 2 over here. That fixes iron. Let's go and update. O3 times 2 is 6. And so plus 4 gives us 10. Hydrogen, 1 times 3 is 3. Times 2 is 6. All right, iron's good. Now, we're saving these 3 for last, so let's go to sulfur. How do we make sulfur good? There's an S1 right here. We need 3. Multiply it by 3. That changes sulfur to 3. It's also going to change potassium and oxygen. What's it change potassium to? 3 times 2 is 6. Oxygen, 3 times 4 is 12. Make a note of that. Oxygen over here, O times 1 times 3 is 3. Times 2 is 6. 6 plus 12, getting high up there now, is 18. All right, these two are good. Now we got to move to our closest thing to a wild card. Can you make 13 and 18 equals? Not really easily. We can make 1 and 6 though. If we need 6 over here, we need 6 on this side. K1 times 6. So now that's 6 potassiums, 6 hydrogens. That's nice. Now how many of those oxygens do we have? 6 times 1 is 6. 4 times 3, 12. 12 plus 6, anybody see what's happening? Balanced. That's about as much work as you'll see that goes into one for what we do. Now, the next time I see you, I'll be explaining that number 9 as well as a couple of other ones, because there's a really shaky technique that you have to use for those ones.